After fieldwork, the written executive report will be compiled, opened on screen, and then debriefed area by area before any remediation begins. This matters because AI-generated apps often run convincingly as demos while hiding the first failure point under real users, real data, or real abuse. Knowing that failure point is the line between a demo and a product. Fieldwork begins now with repository orientation and evidence capture. Repository orientation is complete. This is a small node application with one declared runtime entry point in package.json and no README, tests, CI, database authentication, observability, or deployment evidence detected. Availability SRE review is now entering fieldwork. Dependency failure, slow path behavior, health reporting, and user-facing failure behavior will be assessed from the actual server and storage code. Availability SRE review interim evidence. SRC server.js has no health endpoint, no top-level request error boundary, and no request size or timeout guard before accumulating post bodies in memory. A live probe is being run now to confirm observable behavior rather than relying on code inspection alone. Security review is entering fieldwork. Root protection, input validation, secrets exposure, permissive browser access, and unsafe trust boundaries are being assessed against the files that actually exist. Availability SRE finding recorded. The app responds correctly to malformed JSON, but has no health endpoint and accepts an empty note as a successful write, confirmed by the live probe against health and notes. Got it. I'll walk through what this evidence implies and where the risks cluster. Security review, interim evidence. SRC server.js exposes both get notes and post notes without authentication or authorization. And SRC store.js persists caller-supplied text verbatim. The live probe confirms an unauthenticated caller can create and retrieve a note containing browser executable markup. There is no client in this repo to prove execution, but the stored unsafe payload is material evidence. Architecture and failure isolation review is now entering fieldwork. Routing, storage coupling, shared state, and single deploy blast radius are being assessed. Architecture and failure isolation review, interim evidence. SRC server.js contains routing and response handling in one process and imports SRC store.js directly. SRC store.js owns both memory state and file persistence. A failure in persistence is therefore in the request path, with no isolating queue, service boundary, or fallback. Fault tolerance and recovery review is now entering fieldwork. Crash behavior, corrupt storage, retry safety, and partial write exposure are being assessed with a controlled probe. Fault tolerance and recovery review, interim evidence. SRC store.js silently discards unreadable or corrupt notes.json during startup. And the live probe confirmed the app can restart from a corrupt store by overwriting prior data with the new ID1 note. Scalability review is now entering fieldwork. Growth of per request work, data volume behavior, and first failure at increased note count are being assessed. Scalability review, interim evidence. SRC store.js rewrites the entire notes array to disk on every post, and SRC server.js returns the entire notes array on every get. The live probe confirmed disk size bros with note count, and there is no pagination or bounded query behavior. Performance and data integrity reviews are now entering combined fieldwork because the same storage path controls response time, duplicate writes, and state correctness. Performance review, interim evidence. Each write performs synchronous disk work inside SRC store.js, and the live probe confirmed the all notes response reached 271,385 bytes at 1,000 notes with no pagination. Data integrity review, interim evidence. Retrying the same user action creates two independent notes because SRC server.js and SRC store.js have no idempotency key, no duplicate protection, and no transaction boundary. Release and operations review is now entering fieldwork, test gates, reproducible setup, rollback evidence, CI, and operational documentation are being assessed. Release and operations review interim evidence. Package.json defines only a start script. npm test reports a missing test script. And no README, CI workflow, Docker file, deployment manifest, rollback procedure, or version control metadata has been found. AI integration review is now entering fieldwork. Model calls, prompt handling, AI key exposure, timeout behavior, and unsafe trust in AI output are being assessed. Quality and governance review is continuing. The repository contains no automated test assets, no run documentation, no log file, and a persisted notes.json data file inside SRC. The remaining fieldwork is checking whether this repo carries an additional material area beyond the 10 baseline categories. One moment while I compile the executive summary from the fieldwork. Quality and governance review result. npm audit cannot run because there is no log file. npm test is not defined, and no README or CI evidence exists. Additional material area added. Privacy data handling. Because user-generated notes are persisted directly in SRC notes.json and are retrievable without authentication. Fieldwork is complete, and the executive report is being compiled. One moment. Working. Is being completed in small controlled passes. The next pass covers data integrity, release control, AI applicability, and governance. Exit meeting begins. The report is the governing document for this meeting. Every question and every finding will be handled in depth later during remediation training, but this meeting is the audit debrief. The executive summary states the central conclusion plainly. Lowisa.demo-notes 10 is a working demo, not a production-ready product, because real users would immediately stress security, data integrity, recovery, and operational control. The scoreboard is the audit opinion in compressed form. 10 areas were accessible. One area, AI integration, is not applicable because no AI call path exists in this repo. Of the 10 assessed areas, 0 are ready, which means the app can be demonstrated, but it should not be exposed to real users without remediation. Availability SRE, not ready. The app has a useful small strength. Malformed JSON is handled as a structured 400 rather than crashing the request. The readiness failure is operational visibility and failure control. There is no health endpoint, and the request body grows without a size guard, so operators cannot reliably ask whether the app is healthy. And abusive or accidental large requests can consume memory. The engagement paused briefly. Tell me to resume and it continues exactly where it stopped. Or tell me to jump straight to the report. Availability SRE continues here in the report. The practical consequence is not subtle. Once this app is hosted, a platform or operator has no clean signal for the service is alive, and the server accepts request bodies without a defined ceiling. That combination turns a simple notes demo into a service that is hard to monitor and easier to exhaust. Security, not ready, with the highest severity in the report. The app's strongest point is narrow. It returns JSON rather than constructing HTML directly, which reduces one immediate rendering risk. The controlling issue is much larger. Every caller can read and create notes, and the app stores caller-supplied content exactly as received. So the current trust boundary is effectively absent. Architecture and failure isolation not ready. The code is easy to trace, which is a genuine benefit in a small app, but the web request and the storage write are fused together. In business terms, a storage fault is not contained behind a safer layer. It sits directly in the path a user depends on when creating a note. Fault tolerance and recovery not ready. The app tries to load prior notes at startup, but the recovery behavior is dangerous because a corrupt notes file is silently ignored. In plain terms, the app can wake up with its memory empty, accept a new note, and overwrite the old record of notes without ever raising an alarm. Scalability not ready. The application is simple to start because it has no network database dependency, but that simplicity has a ceiling. Reads and writes both become more expensive as the note list grows. At 10 times the current usage, the first visible failure would likely be slower responses and larger payloads, because every read returns all notes and every write rewrites the entire notes file. Performance not ready. The endpoint surface is small, which keeps routing overhead low, but the expensive work is inside the request path itself. The report evidence shows synchronous disk writes during post and a large all notes payload at 1,000 notes, so normal usage growth would make users feel delays before the code visibly fails. Data integrity not ready. The app does give each note an ID and timestamp, which is a basic record-keeping start, but the identity model is fragile. A retried create can make duplicates, and after recovery or data loss, the same ID sequence can begin again. So the system cannot reliably tell one intended user action from two accidental records. Release and operations not ready. The one operational strength is that package.json contains a clear start command, so the app has a known way to launch. The weakness is the absence of a shipping gate. No tests, no CI, no log file, no README, no deployment notes, and no rollback evidence, which means a bad change can reach users without the repository itself objecting. AI integration, NA. This is not a hidden weakness, it is a scope conclusion. The repo contains no model calls, prompt handling, provider keys, or AI output trust boundary. So AI-specific risks, such as prompt injection and runaway model spend, do not apply to this application as audited. Quality and governance, not ready. The code passes basic node syntax checks, which means the JavaScript can be parsed, but there is no executable regression coverage and no dependency audit path because the repo lacks a log file. In operational terms, the repository cannot prove that important behavior still works after a change, and it cannot even complete a standard NPM audit without first repairing the project controls. Privacy data handling, not ready. The storage format is visible and easy to inspect, but it is placed inside the source tree and exposed through an unauthenticated read endpoint. The practical meaning is that note content is being treated as public application data, not private user data. So privacy fails at both storage location and access control. The remediation section is the action plan, not a soft appendix. Quick wins reduce immediate exposure, but the deep work is what changes this from a demo into a product. Identity, safer storage, item potency, pagination, release controls, and privacy rules. The order matters because security and privacy are the broadest blast radius, followed by data integrity and recovery. How to use this report. It is now a fixed checklist, diligence document, and training syllabus. The production readiness score is 0 ready out of 10 assessed areas. Typical AI-generated demos often land in this zone because they run the happy path but lack the controls that real users, operators, and attackers immediately test. The promise is explicit: security, architecture, fault tolerance, data integrity, release